higher the DQE, it's more able to detect the
Yeah, sensitivity, right? It kind of correlates together.
Yeah.
Good. And then final thing here is that down here, right, when we have resolution versus resolution affected by environmental factors, right? Which thing that we talk about describes spatial resolution, but in a way which is affected by external factors? LSR, good, limiting spatial resolution. All right, you can go to the next one.
So everyone's good on that question? I understand what it's asking.
Almost got me.
Almost. Too smart. So on to excuse me.
So I chose B, but I was between B and I think C.
Mhm.
Because earlier Monty has said, Motor study, she has said that DQE was exposure factors as well as something like that. He said it was affected by something.
It's affected by NTF and signal to noise ratio.
Mhm.
And next.
Okay, awesome. On to question number 2. A technologist uses a low KVP and a mass technique on the patient to give a diagnostic quality image. The technologist then goes to a different X-ray machine and uses the same technique on a patient of similar size. However, this time the image appears to be grainy and poor quality. Which of the following may have happened? So the answer to this is B. So basically, with the new DR, right, we have this thing called dynamic range, right? So it kind of gives us leeway on your technical factors, right? So no matter what DR machine you use, most of the time it's gonna have the same kind of image quality, you know, just because the DR gives you a little leeway on what you can do. So when you don't have that, have you ever seen a CR image where you kind of, the cassette one, it doesn't look as clear? You have to be really punctual with your technical factors, or else it won't look the same as DR. So the same concept goes to here. So the reason why it's B is the second detector has a lower dynamic range. And that's just basically saying it's not in the prime focal of the DR range. What would you add on to that, Mr. Phung?
Okay, so that was a pretty good explanation, right? So for this one, I do want to kind of talk through the different answer choices. So when we see image appears to be grainy and poor quality, what does that kind of tell you?
Quantum noise, less
Quantum
exposure,
noise.
less
Good.
exposure.
Right, so our mass or our exposure factors were too low for this image for some reason. Right, but we said that we used the same technique, right, the same exposure factors on both images. So we know that our KVP and our mass aren't changing. So something happened which is causing us to have quantum noise still. Something is happening that's causing, something's happening at the detector, right, rather than happening at our KVP and our mass. So, does motion cause quantum noise? No, it doesn't. The most it'll do is it causes blurring, right? It'll cause a loss of spatial resolution, cause the image looks smeared because your patient was moving. Okay, too much mass. If there's too much mass, will we have quantum noise?
No.
No, that actually
So
helps.
too little quantum.
Right, it's actually the opposite, right? Too little mass is what gives us quantum noise. So it can't be C. And then D, histogram analysis error. What is that? Right, so it can't detect the collimation border, so it gives it the whole thing, including the stuff outside our collimation, so we have white on the outside of our image. Right, and that's not what's happening here. So you can sort of eliminate A, C, and D. So then the question is dynamic range. Why dynamic range? If you have a wide dynamic range, even if your exposures are low, it's still going to give you a good image. But once that dynamic range narrows up, now those factors may be outside your dynamic range and it gives you a poor quality image. Does that make sense? So it's just the amount of leeway, like Jalen said, right? If you have a lot of leeway, it's going to be in range. If you don't have enough leeway, it's going to be out of range. So also related to exposure latitude. Okay. Any questions about that one?
Everybody gets the concept of what the dynamic range is, and if you're after the range, it would look different than when it's within.
Has a wide.
Wide range, yeah. So whenever you take an X-ray, no matter what it is in the scale, as long as it's in here, most likely it's gonna look the same. But once you step outside of it, the dynamic range, that's when you go to the starting to look, the image starts to look funny, you know. It's like a hit or miss kind of thing.
Correct. So,
Either way off, way under, or yeah, it's just one of those two. Everybody gets that? Everybody's good? Awesome. Alright, on to question number 3. This one was a fungal fact question. So a technologist is performing an exposure using a manual technique with a CR image receptor, and notice that the S value is very high. Which of the following factors may have caused this issue? So does anyone know what an S value is? We don't really get to see that much. Yeah, so S value is basically the signal to noise ratio. So the higher the S value, the better the image quality would be, correct? Or is it vice versa?
so this one, so S value is about your exposure indices, right? So S value is your exposure index. Depending on how much exposure you have, the S value will tell you if you had a good exposure or a bad exposure. But like I heard, I think Melanie said, S value is inverse. So if the S value is too high, is that over or underexposed? That's right. So too high means underexposed. And if the S value is too low, now that's overexposed. Great. So in this case, the S value is too high. So Carla, is this image underexposed or overexposed? This image is underexposed. So we're looking for factors that can cause underexposure. And when we say underexposed, Veronica, do we mean we have too many X-rays or too little X-rays? Too little X-rays. So we want something that causes the number of X-rays to go down, right? We have too little X-rays. So Janelle, if the SID is high, if we increase the SID, what happens to the number of X-rays reaching the IR? It decreases. And what law tells us that? Inverse square law. Very good. Okay, if our grid ratio is low, then Shameka, what happens to the number of X-rays? If we go from high grid ratio to low grid ratio.
They won't. Guess it increases. It gets the, I don't know. I'm be confused with the grid ratio stuff anyway, so.
So in this case, if we have a lower grid ratio, it means the grid isn't blocking as many X-rays. So more X-rays get to go through. So what happens to the number of X-rays that reach the IR? If more X-rays are going through the grid.
It blocks, the grid blocks them.
So the grid normally blocks the X-rays, but in this case, with the low grid ratio, now more X-rays get to pass through the grid. So how many X-rays reach the IR? More or less? If more are passing through the grid, what happens at the IR?
More?
That's right. If more get through the grid, more get to reach the IR, right? So the grid's not blocking as many. So more X-rays, right? Once again, that's the number going up. That's the opposite of the question. Yes, Melody.
But either way, the grid doesn't have more sections are going through just because there's a grid already. So, like, the question is.
Right, but in this case, we said the grid ratio was too low, right? So we're implying that we should have used a higher grid, but we used a lower grid. Does that make sense? We're not saying we went from no grid to a grid. We're saying we went from a high grid and we're now using one that's too low, a grid ratio that's too low. Right? So the too low here is your key part of that question, or that's the answer choice. Right? If we said the grid ratio was too high, now we could say yes, that means we're going from no grid to some sort of grid. But if we're saying too low, that means we went from a really high grid ratio down to something that's lower. But if you go from a high grid ratio to a low grid ratio, you increase the number of X-rays reaching the IR, which is not what should be happening.
Okay.
Yes?
So grid is kind of like a filter. If it goes down, it's supposed to move more. Or,
Yes, you can think of a grid kind of like a filter. It's still blocking X-rays. And speaking of filters, John, D, if the filtration was too low, if we have less filtration, what happens to the number of X-rays?
because it's more.
That's right, then more X-rays get to pass through, and once again, the number of X-rays goes up. Right, so B, C, D, all three of these will increase the number of X-rays reaching to IR. The only one that reduces the number of X-rays is SID being too high. So that's most likely what caused it to be underexposed. Right? Longer SID, fewer X-rays reaching to IR, underexposed. Does that make sense?
So,
Yes, Shaheen.
longer SID, why do fewer excisions?
Inverse square law.
Oh, I see. Sorry.
All right, Jalen, let's go to the next one.
Okay. Alright, on to the next question. Everybody gets number 3, correct? The phone explained it. Got it? Awesome. So number 4, a radiographer takes an image of a thick part with a grid ratio of 8.
You didn't answer.
8.1.
Number 5.
The next patient has a part which is 5 centimeters thicker than the first patient. The radiographer decides to use the same exposure factor but switches to a 5.1 grid in order to maintain intensity at the IR. What is the potential issue that would result from this? So once again, the radiographer was using an 8.1 grid, and then the next patient that they used had a 5 centimeter thicker. So technically, when someone's thicker, you want to use a bigger grid ratio than 8.5 or the previous one. But instead, the tech decided to go one below. So what does that mean? So what's the whole point of the grid, right? Does anyone?
Wait, you said if we have a thicker patient, we go to a bigger grid.
Yeah.
To reduce scatter.
Yes, you reduce scatter,
Mm.
increase contrast.
More thickness, more scatter, so
Yeah.
you use a
Yeah.
higher grid ratio.
Sure, is more scatter,
Exactly.
less contrast.
With increased mass as well.
Yes.
Oh, okay.
You increase the mass too. So the only downside of the grid is to it increases patient dose, but you get a better
You
image
get a
from that.
better image,
Yeah.
more contrast.
So instead of the tech, he probably went to San Jack. He decided to go one below. And so by doing that, by having one less grid, that means there's more scatter within it. So the best answer for this would be A, right? A thicker part. That's what they said, a 5 centimeter thicker than the previous patient.
Yeah,
But he decided to lower the grid ratio, which means he increases the scatter.
Yeah.
Correct?
yeah.
So that's kind of explanatory. You want me to go over the other questions, or does that make
No, that's
sense.
perfect sense.
sense? Okay, awesome. So everyone's good on that? Everybody understands the concept of why we use grids and why do we increase?
Yes,
Yeah.
no, just checking.
Awesome. And what was that equation? Like every 5 centimeters you increase the...
That's right, for every 5 centimeters, you need to do what to the mass?
Double.
Double your mass to maintain intensity.
That's a test question that will show up, so make sure you remember that, okay?
That was every 5 or 10.
Every 4 to 5 centimeters.
45.
1.52 inches.
Very good.
So everyone's good? Alright. So, question 5. A radiographer takes an image of some thick anatomy and notice that there appears to be quantum model. Which of the following could be a cause? So what's another name or a couple of different names for quantum model? Quantum noise, yeah, or you can get graininess, that's another word they may use. And so basically when there's a lot of tissue that's really thick, there's a lot more attenuation. So that means the X-ray doesn't get passed to the patient and it doesn't reach the image receptor.
Less exposure.
Less exposure. So yeah. So when you read out the questions, these are kind of, you really have to read into the question because it's not really right there for you. So the correct answer is D.
It's the,
Yeah, the radiographer uses a grid with too high of a grid ratio.
Yep.
So think about it, guys. If your technical factors are already low and you already add a thick grid on top of that, you're not getting too many receptors to the image receptor, right? So that's why it produces such high quantum noise or graininess, correct?
yes,
Does everybody understand that concept?
yes.
Right? Because you have to conclude the grid plus the patient. So you have to have a high enough technical factor to get past the patient, past the grid to be able to reach the image receptor.
So anytime we talking about thick anatomy, we gotta use a higher grade, of
Higher
course.
grid, but you need them up the mass.
Higher
So every,
grade too.
so every time you up the grid, you also up the mass.
It's mass increase.
Yeah.
the ratio need to increase.
So you're trying to maintain intensity by doing that.
So you have to increase.
So there's gonna be a test question. It's not on here. There's gonna be like Okay, if we move up the grid, which one would you want to change first for the technical factors? KBP or mass?
The mass.
Mass, okay, so everybody knows that?
Yeah, you know that.
Okay, my big.
No, I'm saying I understand that, but I mean, when I see this type of stuff, I just be like, I ain't.
So do you understand question 5 or I can?
That's what I'm saying. So, of course, I mean, I understand when you have the thick anatomy, you gotta use a higher grid.
Mhm.
But the quantum noise, that's
The concept of quantum noise, is that what you're
no,
asking?
no. I mean,
There's less X-rays going to the IR. Why is there less?
because of the
X-rays?
grid.
Because of the thick anatomy, there's less X-rays going through.
Also the
Okay.
So it's asking, so break it down. So the question is asking, why is the quantum noise appearing? Like what
Right,
is most
yeah.
likely?
Yeah,
Why
that's
is the
what I was.
quantum noise appealing, right?
Yeah.
So we already know that we need high factors to get past thick anatomy, right?
Mhm.
But on top of that, you had an extra layer of grid ratio. Like, the grid ratio is way too high already.
Mhm.
So if you're blocking, if the anatomy is already blocking the X-rays, and you already have the grid ratio that's blocking enough, there's not going to be enough X-rays to fully penetrate those two to reach the IR. Does that make sense? It's just like thickness, and then you're trying to pass that. You know what I'm saying?
Okay.
But if it was like 2 thin people, it'd be really easy to
Oh, yeah,
have
to go
all
through.
those X-rays to go through.
Now, one more thing that I will say is that, at least for me, when I make these questions,
Mhm.
oftentimes, if you look at the answer choices, ask yourself for each answer choice, what is happening to intensity? So if we increase the mass, what happens to intensity?
Increases.
Goes up. Okay, if you change our focal spot, what happens to intensity?
larger focus point.
Nothing.
Nothing.
Focal spot only affects facial resolution.
And so if we do not use air gap technique, right, what happens to intensity?
Increases because this is scattered because I get technique is
That's right. So if we have less OID, right? If you have no air gap, your intensity will increase. And what happens if you use a high grid ratio?
it will decrease.
It decreases. So you've got up, nothing, up, down, right? So chances are it's not going to be the ones that both go up. It's going to be one of the other two. We know. So then we have to go back to our question: quantum motto or quantum noise. As long as you remember that quantum noise is associated with not enough X-rays, you just look for the one where the number of X-rays is going down. Does that make sense?
Perfect.
Okay.
So underexposure
Yes.
causes quantum model?
So underexposure causes quantum motto. Very good.
Mhm.
All right. Let's take a look at number 6.
Everybody's got a number
Wait,
5
so
and why that's
quantum
correct.
noise and quantum model.
Everyone's
Same
got
thing.
So on to number 6. This is where the math begins. Okay. So X-ray tech is performing an abdomen X-ray on a patient with a source to image SID of 100 centimeters and a mass of 4. The radiographer needs to maintain the same intensity as the image receptor when the distance is changed to 120 centimeters. What should be the new mass? So like I always say, guys, always work with what you're given and then see what the question's asking. So it's already given us 2 SIDs, 2 distances, right? So you have your number 1, your first SID is 100 centimeters, right? The second one is 120. So you automatically know that, first of all, what kind of equation is it asking for?
It's gonna be either inverse or direct. We're looking at just that same.
But if it's asking for maintain, what does it mean?
Mass
Maintain will be direct.
Mass.
Direct mass, right? So the keyword to this type of equation is maintain. So maintain can already tell you what type of equation you would use, so you already know it's mass, right?
Yeah.
So that correlates to direct square law. So maintain equals direct square law, right?
Right.
So let's repeat, what is the equation to direct square law, so we can remember?
Mass 1 over mass 2 equals distance 1 squared over distance 2 squared.
Yeah. So they're both direct, right? So MAS 1 on top, and then distance 1 is on top too. And then mass 2 is on the bottom, and then distance 2 is on the bottom. So you want me to do the math up here, or you guys
What's one whole?
say math up there? Now y'all, okay, you're good. So when you do the cross multiply, what number do we get?
Oh man.
Once you-
5.7.
Okay, I think I'm gonna write it up here. How do you do the word thing? Come do your magic real quick.
I'm doing magic, okay?
Magic Phung, that's what.
Hmm?
So what are you trying to do?
Just stick magic.
I got 5.76.
Oh, how cool. Yeah, turns around and change the wrong answer.
Shit. It gets me.
Oh my, I don't need it.
Hansi,
So I'm just gonna do this one real quick. Real quick. So we get the mass right. Original mass is 4.
oh,
And then the first one, it's 100. So you just square that.
Yes.
That gives you 10,000. Right.
Yeah,
And then second one, what was the second?
14,
14 4. Alright, so you cross multiply, so you do the 14 times 4, then you divide it by the 10,000, and that gives you a whopping number of what?
5.8, but it's 5.7.
6. But then you round, and then 5.8.
That part.
Everybody gets the whole concept on what that's for. So what's the key word to finding out if it's maintained, right?
where did you change it?
Because I
Did
was
you-
looking at, I don't know what I was thinking. I was thinking of.
Would you agree with that, Mr. Fong? How we
I
saw
probably thought of the inverse
Sorry.
square law.
Oh,
I did the
I
same
was just asking,
thing.
like, would you agree?
Ended up switching it instead of direct.
Yep.
Yeah, just the way I described
I
it.
was trying to think about
Alright, on to question number 7, okay?
increasing or
A
decreasing.
X-ray tech is performing a chest X-ray on a patient with a source to image distance SID of 100 centimeters. If the X-ray tech moves the X-ray tube to the distance of 150 centimeters,
Yeah.
what would be the new intensity of the image receptor? So as you can see, you don't see the word maintain, right?
Nope,
And it's asking what is the new intensity?
sounds like inverse square law of division.
Exactly. And then we know when you Bob,
I couldn't do this one.
you couldn't do this one. What was the hardest part when you tried to solve this?
I first said 100 square by 150 square. I just wasn't able to do it. If you could work this out, I'd really
Okay,
appreciate it.
so I can see why you got confusing because it doesn't give you a number, like it doesn't give you an intensity number. So that's why when it doesn't give you an intensity number, that's why you just put a random number. You can just do 1 or any type of number, but I preferably just like to use the
Or
1.
X, or just
Yeah.
put X.
No, don't
do
put
X
X.
then.
No X.
No.
Because it'd be 2 X.
Oh, that's why I couldn't do it, so I tried it.
So, real easy way for these questions, especially if it's about a percentage. What is, if you have everything, what percent is that?
100.
So what you start with is going to be
100.
100%. So just assume you start with 100%. Okay? Your 100% is going to be your baseline, and then you see yourself either go above 100%, which means you gain, or you go under 100%, which means you lose, right? But just start yourself at 100%. Even if it doesn't give you a number, just assume 100%,
Which is 1. Which is
Mhm.
1. So,
which is one.
so which equation will we be using for this?
Inverse.
Square law, right? Because we want to find the new intensity. And as we all know, the farther you put the SID back, what happens to the intensity?
Goes down.
Decreases, right? And so you already know that since the original starting point was 100, it goes to 150. You already know you can take these 2 out, right?
Yep, 2B.
C and D. So you're left with these 2, right?
Yep.
So that now you're stuck with the equation. And what's the equation one more time?
If you go up 15%,
Or
you
just
go
do it in your
down half.
Alright, you take a Charles. Go ahead. What's the intensity? What's the equation?
I said if you go up by 15%, you go down in math by half.
No,
No, no,
That's
no.
15%.
15%.
I-
I
Yeah.
one over I2 equals D2
Oh,
squared over
go
D1
ahead.
squared.
Yeah, the inverse square law. So once you
Oh,
plug it all in,
inverse square law.
So then so please send me to do
All right.
this because I really.
We'll have to do that during study hall.
Why, sir?
But
Because
now,
we
let's
have-
move to the next
So
one.
you said I
We
want
would
to
work number 6 by
Not now, Shaggy. Let's talk about it during study hall. Just mark it down.
B inverse of D2
either do
squared
this one
over
ahead.
All right, so real quick, number 8, what do we have? We have exposure time, we have KVP, we have an increase to KVP. What's the new exposure time to maintain exposure? So normally, what would we be thinking of doing? If you see KVP,
Inverse square law.
Inverse, yeah.
if you see KVP, the first thing you would normally think of is
15%.
Oh,
15% rule, right? The only time you've seen KVP in an equation is 15% rule. But normally it's KVP and what?
Mass.
Mass. Do we have mass? No, but we have what?
S.
Is seconds part of mass? Yes, right? Exposure time is part of mass. So you don't need to actually only use mass. You can do 15% rule off the exposure time. You can do 15% rule off the MA. Mhm.
Because if you change seconds, you also change mass.
Because if you change seconds,
You also change-
you're changing mass. Right. So, for this one, 15% rule, KVP goes up by 15%. So what mass needs to do what? Go down by half. In this case, rather than changing mass, we're going to change time. Time down by half will give you our 0.025. Does that make sense?
All you did was, what you do? So the 0.05?
Divide by 2. 15% rule.
So 15% of 80 is 12, sir.
Yes. So we went up 15%, we go down on our mass. Let's talk about number 9. So this one is just about maintaining mass, right? So you calculate your mass here, 0.5 or 0.05 times your 400, and then afterwards you just divide by your 500.
So you just try to get the same number.
Mhm. Jones.
I couldn't remember how to do it, so I just multiplied 0.05 to 400,
Mhm.
and I got like 20.
20, yeah.
So I did 500 times 0.04, 500 times 0.05 until I got 20.
Yeah.
Just tried every single one.
Okay, that works too. Yeah, you can do that. Works.
Yep. You only have-
That's the elimination. You still get A's.
Right, so Jalen, number 10.
Everybody gets the concept of number 9, right?
Yeah.
Okay. So, number 10, what type of X-blusher? What type of X-ray generator produces the greatest exposure to the IR at 100 kVp and 2.5 mass? So so everybody knows it's high frequency.
It's just greater exposure. Next.
Yeah, exactly.
Okay, so just real quick, do these numbers actually matter? No, that's just fluff, right?
Greatest exposure.
Just remember, high frequency is higher exposure.
Does anyone know what's the number for high frequency? Yeah. and
That's
you
our heat units, good.
And you also have 3 more. But should I explain to them?
Next.
So question 11, we're skipping that.
Mhm.
Let's go on to it.
Okay. Number 12, when the part thickness of the patient increases, what should be done to maintain intensity at the image receptor?
Increase mass.
Increase mass.
Just how we talked about with one of the equations earlier, you want to increase mass over KVP. Everyone understands that, correct? Okay. Number 13, what effects does annulation of the CR have on the image? Elongation. And what does that also affect?
Spatial resolution.
Yeah, spatial resolution.
That part.
Awesome. Okay. At the source to image, SID increases. What happens to the magnification of the image?
Decreases.
Yes, awesome. Did Mr. Phung ever show you like the light with the phone?
Yes.
With the hand,
That's
yes.
Always use that when in doubt. Okay. Number 15. When using a high grade ratio, what happens to the intensity of the radiation reaching the image
It decreases.
and decreases, right? Awesome.
I guess,
Do you understand why we did that though?
I just seen higher and I went lower, so that's how I guessed. Like I said, I guessed.
It's okay. We'll talk more about this in the next
Okay.
chapter.
Okay. Number 16. To maintain intensity at the image receptor using mass, when the distance SID changes, what law should we use? It's talking about mass.
Direct.
Direct, right? Awesome. Because you see the maintain and you see mass in there as well. Alright, number 17. According to the inverse square law, if the distance between the X-ray source and the image receptor is halved, what happens to the X-ray intensity at the image receptor?
It's quadruple.
Quadruple, right? Because the inverse square law, anytime you go forward or backwards half, it multiplies by 4 or goes down by 4.
You know, I fought myself on that. I knew it was quadruple, but I was like, six.
I was gonna say quadruple, but I was like,
Yeah, I was like, we never.
Alright. Question number 18. When increasing the KVP by 15%, what rule is that?
15%.
15%.
What should be done to maintain exposure to the image receptor? So yeah, because it's saying maintain exposure, so you're giving up something to kind of balance it out. So KDP goes up, mass goes down, right? So that's why we would decrease the mass by 50%. Everybody understands this?
Yeah.
Right? Okay. Number 19, this is one of the questions you just kind of have to know. What is DICOM in radiography? DICOM.
Who laughed over there?
Bro, I couldn't hold it in, I'm sorry.
DICOM in radiography.
Soft tissue over there is laughing.
You laughed too, Mr. Fuchs. I saw you
Standard
smile.
of storage and transmission.
Say that one more time.
That one had me going back and
Yeah,
forth.
I had it.
And so, what's the full abbreviation for
Communication.
medicine? Awesome, excellent, perfect. And then we all said, what was it again?
DICOM.
A standard of image storage and transmission. And diagram.
It's all right, Jayla. It's
Go home. Hey.
So, this one's more the confusing one because you really got to know all types of test patterns out there. So, what is the purpose of a TG18 test pattern in radiography?
To test the performance.
Would you like to explain this, Mr. Phung?
Right. So just remember, right, your TG18s, right, we've got all different types, right? We have our QCs, ADs, LMs, UNLs, right? But all of those were just to test the performance of the monitors, right? Test the quality of the monitor, the reflection, the luminance, right? Whether the brightness changes depending on the angle you look at it. So the resolution, right? So TG18, that group of test patterns is there to test the monitors. Okay, very good. 21.
All right, 21.
Hang on.
21. What is a histogram in radiography?
A graphical representation of physical values and reviews.
Does everybody know what it looks like too?
Yeah.
Alright, awesome. Because you get a lot of questions on like, what does the x-axis represent, and what does the y-axis represent? So get to know the graphs like that. X is, say that again?
So X is your values. That's not necessarily of interest. Just your values. Some of them are your values of interest, but not all of them. And then your Y is the number. Yes. Okay.
If you took number C from 21 and applied it to 20, would D still be the better answer for number 20?
So it has to. What do you mean?
Well, if you took C
Yes.
from 21 and
Uh-huh.
applied it to 20,
Yes.
would D still be the best answer for 20?
Yes.
Yeah? Okay.
Yes.
Okay. Everybody understands 21, right? What is the purpose of the analog to digital conversion of radiography? Another name for analog to digital conversion is also known as ADC. And basically the whole concept of the ADC, or analog to digital converter, is that it's basically taking the X-ray and digitalizing it to make it smaller to be able to show up on your screen, basically. So remember film? You guys don't remember film, but they used to take X-rays on like little papers. You had to hang it up. So instead of doing the whole process, they just convert it to like code and like digitize it to be able to read it off the screen. So the correct answer to this is B, to create a signal which can be processed by the computer. And that makes sense for everybody? And like, what's the whole point of ADC?
Let's finish up.
Okay, so number 23, what is the fill factor in radiography? So the fill factor, this can be found in your set. So basically the fill factor is there's like a square inside of a bigger square, right? So the bigger square is what's actually being read, and there's a bigger square outside of that square, and it's like for the like that. What would you explain that?
That's right. Good.
Inactive and active layer. So the correct answer to this is the ratio of the exposed area of the detector to the total area of the whole area of the detector. So yeah.
And remember, when we say detector, right, this is our detector element, our DEL. So our whole del has electronics and stuff in it as well, but the part that's actively detecting X-rays, right, that is our active area. So active to total, active over total. Good.
Everybody understands the whole concept and what EL and inactive, active area is? So the active area, which ones are located? Inside, right? Awesome. So number 24, what type of technology is used in DR radiography? So this one is pretty easy. Well, so what would we put for this one?
C.
C, right? And everything else is mainly found in the CR, right? Okay.
So for charge coupled device, what kind of DR imaging is that? Indirect. Very good. And our final question.
Final last one. This has to be the hardest one out there. What is the purpose of the cassette in the CR radiography? And then bonus question, how many layers are in the PSP plate?
5.
Okay.
Professor
You want to
really doesn't
list it out?
What is
You want to list them out?
that? No.
5 layers?
Let's have all 5. All right, so John's first layer of the PSP plate,
Professor.
which stands for
Protective
protective.
layer.
Okay, good. And then Shaheen, second layer.
From pH
Everybody pay attention. This is a test question right here. Big.
Protective. Is that pH?
You got it.
phosphorus.
Phosphor layer. Great.
There we go.
Shamika, third layer.
Reflective.
Woo! Or not.
Professor Phung can't sing.
Professor Phung really can't sing.
Good. Reflective.
Yeah.
Okay.
You was
Second, number 4.
Who is the pause?
Conductive. Good. And then Samantha,
Support.
support layer. Very
Hey,
good.
congratulations right there.
Very good.
Do they have to know the color?
No.
No.
They don't
We learned about it, but we don't.
We don't need to. Okay. Well, yeah.
Okay. All right.
All 25 questions right there. Good job, everyone.
Great job, everyone. Okay, so
Wow.
just a reminder, we will be starting chapter 12 on Wednesday. I believe you already have the PowerPoint, so please start looking over it.
Did you put any, concept there? I mean, yeah.
I am gonna put the new cards up this afternoon. I'm still working on them.
Okay.
Yes, Jay.
So B on 24 isn't correct because we do that, or we used to use that in CR.
Photo multiplier tube is used in the CR reader.
Chapter 12?
Okay, so that was
When
with
is
the
it?
photo timers and whatnot.
Not with the photo timers. Photo timer also use the photo multiplier tube, but that's in your AEC.
Okay.
So you will see
Different.
photo multiplier tubes in 2 places.
Okay.
AEC, which is the really old style, and then your CR reader,
Okay.
which is your photo detector. And then Shaheen, did you have a question on the previous one?
So number 7, of course, number 7 and 12.
7 and 12.
My head is turning up, yeah.
So 7.
So what is your question about 7, Shaheen?
So 7, I was not able to
Thank you,
do.
Jayla.
Yes, sir.
A radiographer's performance as X-ray with an SID of 100 centimeters. And if the graph involves the exchange distance of 150 centimeters, D2 is 150. What will be the intensity as the image receptor? So I1 over I2 is equal to D1 square over D2 square.
No, that's not inverse. Your 1s are on top, your 2s are on bottom, so that's not inverse.
So when you think of inverse, you know how it's like
Is
completely
it
different.
just, oh, yes, this has to be on top, and
Yeah.
150 is
So, yeah.
150 square over 100 square.
Uh-huh.
So then I will go by to we know
So-
now that you're saying that we don't have numbers, right? So if I just did this,
No, so with this, it's automatically, there's no number, right? So you have to make up a number. So the easiest number to make up is 1, because we always start at 100%, right? And 1 equals 100%. So
1 over 2.
no, it wouldn't be 2, it would be x, because you're trying to find the new variable,
Oh, I
right?
see, then this I didn't know, so this should be 1 then.
Yeah, it should be 1. And the reason why you don't
Yeah,
put
I
2,
did this wrong, but I know I didn't, but I didn't do this.
Yeah, so don't put 2, because if you put a number already in there, it's basically kind of solved. Because you already know what
So we don't know
your
what
variable
X
is.
is.
Why are you putting the 100 on top, Shaheen?
No.
150 squared X is.
So,
Shaheen.
Okay.
the best way to do
So
it.
if you're doing this, then it is X is on the top, so and this goes down. 100
So-
square will go on the top.
So this is what?
150.
Okay, that's 150.
So 100 square over 150 square.
Why are you doing that? No.
No, the best way to not get confused, whenever you have a square, automatically solve it. So it can just be a regular number, right? So just square these first, square that first, and these are the square numbers you
Yeah,
get.
but generally I like to work
do
with
that?
smaller numbers so that we can just dance them. Just if you want me to do that, and 150
Shaheen.
So I don't know what was going wrong, so yeah.
No, Shaheen. So this is 150.
Yes,
Alright.
sir.
This is 100.
Yes, sir.
So what is 150 squared?
350 is 625.
Quarter.
Oh, 500.
Should be